Hi guys, welcome back to the second part of the Simplifying Radicals video. This video we're going to talk about adding, subtracting, multiplying, and dividing radicals. And we're going to begin with multiplication. So we need to talk about the multiplication property of square roots. So if I have the square root of a times the square root of b, all I have to do is really just multiply what's on the inside. So I have the square root of a times b. Okay. So I have two square roots. If they're a square root, then I can just combine what's on the inside and multiply them. So over here, with the second part, I would still have the square root of a times b, but on the outside, I would have x times y, okay? So whatever's on the outside multiplies, whatever's on the inside multiplies. All right, so we're going to simplify. Number one. Okay, well here I have, inside my radicals, I have 7 and I have a 14. So it's going to give me the square root, what is that, 96? 14 times 7, 98. Okay, so 14 times 7 is 98. Okay, and then the number on the outside is 3 and technically a 1, so 3 times 1 is 3. Okay, so you multiply what's on the inside and then you multiply what's on the outside. Now I need to simplify this, so I'm going to divide this. So I have, I'm going to divide it by 2. So let's see, 98 divided by 2 is 49. Okay. And then that would be 7 times 7. So again, I'm still crossing out stuff, making my factor tree. 3 square root of 98 is technically equivalent, and you have multiplied them, but you need to simplify the radical as well. So here I have one pair, and I have one child that's going to go back inside the house. So I have the original 3 that was already on the outside, and then I have the parents that are going to take one car, which is the times 7. And then I do have one child that's still on the inside, which is the square root of 2, okay? So 2 is going to go back inside. And then to simplify that, I would have 21 square root of 2, okay? Number 2, again, same thing. You're going to multiply what's on the outside, so I have 4 times negative 6. That's going to give me negative 24. And then the inside of my radical, I have 5 times 7, so I have square root of 35. Now, if I try to make a factor tree with this, I'm going to have 5 times 7, and I can't keep going, and I don't have any pairs, so both of those children are going to go back inside the house. So I can't actually pair them off with anything, so they'll just stay that way. So this would be my final answer. Okay. Next, for number 3, again, multiply what's on the outside. Negative 4 times 2 is negative 8. And then I have square root of 7 times square root of 7, which is going to be the square root of 49. Okay, now 49 I can break off into 7 times 7, and then those are prime numbers, and that is actually a pair. Now when I have no children, when I just have all parents, I have all pairs, that means it's a perfect square. So I'm only going to have one car here, so I have negative 8 times the 7, which is the one car, and that would give me negative 56. Okay. I don't know if you noticed, but I did square root of 7 times square root of 7, and in the end I ended up just getting a 7. So when you have a square root that has the same thing on the inside, multiplying by another square root, it's just going to be whatever's on that inside. Because the square root of 7 times the square root of 7 would be the square root of 49, but the square root of 49 is a perfect square, so it's just 7. Or if I have square root of 5 times square root of 5, that would give me 5. So if I have the square root of x times the square root of x, that would give me x, okay? So whatever you have, if it's the exact same thing being multiplied together, you'll get the same thing that's inside the radical. For example, over here, I have the square root of 6 squared. So that means I have the square root of 6 times the square root of 6. I'm multiplying it by itself twice. Now, let's do it the long way. So square root of 6 times square root of 6 would be square root of 36. And I know that this would be, let's do 9 and 4. And then I have 3 and 3 and 2 and 2. Okay, so I have a pair of 3s and a pair of 2s, no children. So that means they're going to take one car, which is a 3, and one car, which is a 2. And that gives me 6. And no children left in the house. But I knew that already at the beginning because I had square root of 6 times square root of 6. So basically, they cancel each other out, and I just get a 6. They don't really cancel each other out. They kind of mold into one thing. All right, number 5, I have 2 square root of 5 twice, so I'm going to write that twice. And then here you're just going to multiply whatever's on the outside of your radical. So that'd be a 4 And then square root of 5 times square root of 5 is going to be the square root of 25. Okay, and the square root of 25 is 5. So I have 4 times 5, which equals 20. Okay. Lastly, number 6, this one's a little bit different. The square is only on the radical 2. So I have 5 square root of 2 times square root of 2. So I have the square root of 2 twice, but not the 5 twice. Okay, and then square root of 2 times the square root of 2 is the square root of 4, because you multiply the insides. And then the square root of 4 is 2, which gives me 10 when I multiply those together. So that is how you multiply. Multiplying is actually the easier one out of the 4. It's probably the least amount of work out of the 4 ways. Next, we're going to talk about the division property of square roots. So if I have a fraction that is being divided, or not divided, has a radical over it, I can split the radical into 2 parts. So I can have the square root of a over the square root of b. Now this goes both ways. If I start off with 2 separate radicals, I can end up putting them all in one giant radical. Now this is important. In order for an expression to be completely simplified, there can be no square roots in the denominator, no radicals. Okay? So if there is a square root in the denominator, it is not simplified. All right, so let's begin with number 1. I'm going to apply that property, the division property. I'm going to split that square root into 2. So the square root of 64 over the square root of 49. Well, I already know that 64 is a perfect square. Now I can do the factor tree and you'll end up getting the same answer, but I already know that the square root of 64 is 8. And I know the square root of 49 is 7. Okay, so that one's all simplified. That one's pretty easy. Again, you can always check these. You can punch this in the calculator and hit enter, and then punch this in the calculator and hit enter. You'll get the same answer. All right, number 2 is actually a really easy one. It's kind of like if you had 5x divided by x, your x's would cancel and you would only have 5 left. So here I have 5 square root of 3 divided by square root of 3. The square root of 3's are going to cancel and I just have 5 left. Okay. The next one I have is number 3. Now, this one doesn't work out as nice as all the other ones. So I know that the square root of 36 is a perfect square. That's going to give me a 6. However, square root of 24 is not a perfect square. So I do need to go over here and go ahead and simplify that radical. So I'm going to choose, let's do 6 and 4. Okay, so I have 2 and 3 and 2 and 2. Okay, I have 1 pair and I have 2 children that are going to go back in the house. So that's going to give me 1 parent on the, or 1 car on the outside, and then I have the 2 times 3 on the inside. So that'd be 2 square root of 6, okay? And that's going to go in the numerator here. And then I ask you, are we done? Can we simplify this even further? And we can, because 2 divided by 6 is 1/3. So I really have square root of 6 over 3. You could put the 1, but it's not something that we typically do, so I'm not going to. Okay, number 4, now I have a square root in the denominator. So this is our first instance where we're like, okay, what do we do? 2 is simplified. The square root of 3 is simplified as possible. So what I need to do is I need to rationalize the denominator. So we need to rationalize. Oh my gosh. That was annoying. Okay. I need to rationalize the denominator. Okay. Now, in order to do that, I'm so sorry for the phone call. I need to put like a little like sound warning, like if you're wearing headphones, it's gonna get loud. Okay. Okay, so in order to rationalize the denominator, I need to get rid of the radical in the denominator. Now, let me ask you this. When we had the square root of 7 times the square root of 7, how did we get rid of those square roots? In order for it to be gone, in order for that radical to no longer be there, you have to multiply it by the same thing, by itself, and it will get rid of the radical. So, since I have 2 square root of 3 and I want to get rid of the square root of 3, I'm going to multiply by the square root of 3 over the square root of 3. And you're like, why? Well, we don't want to change the expression, so it's kind of like making common denominators in fractions. You can multiply by 5 over 5 or 2 over 2 because you can only multiply by 1, okay? Because multiplying by 1 doesn't change the expression. So that's why we have to multiply by square root of 3 over square root of 3, okay? And then you would multiply like normal. You have 2 times the square root of 3. and then you have the square root of 3 times the square root of 3, which is the square root of 9, okay? Now, if you can already do the shortcut in your head, that's awesome, but I'm going to keep going and simplify this further. So the numerator I can't simplify anymore because square root of 3 is a prime number. However, the square root of 9 is a perfect square, and that gives me 3. And now I am done. So there's no longer radicals in the denominator. You can have them in the numerator, just not in the denominator. Number 5 is the same process. I know that I have a radical in the denominator, so I need to multiply and rationalize it by the square root of 3. Okay? So this would be the 9 square root of 3. Square root of 3 times the square root of 3 is the square root of 9, which is 3. Okay? So here I'm just doing that trick. I know that these are going to multiply, and it'll just be whatever's on the inside. Okay? Now I'm almost done. I can simplify this one more step. I can do 9 divided by 3 here. So that's going to be 3 square root of 3, because that simplifies. All right, so that is dividing radicals for you. And there's obviously harder problems out there, but this is kind of just the basics. All right, adding and subtracting radicals. In order to simplify radicals by adding or subtracting, I must have like radicals. I wonder if you guys can hear the thunder that's happening outside right now. All right. Now, like radicals sounds kind of like weird, but it's the same concept as like terms, okay? So combining like terms and combining like radicals are the same concept. So combining like terms, if I have x plus x, then I have 2x's. I have 2x. Now if I have 3x minus 2x, then I have 1x left over, so I just have x. Combining like radicals is the same thing. If I have square root of 2 plus square root of 2, how many square roots of 2 do I have? Well, I have 2 of them. 2 square root of 2's. So instead of x's, now we have radicals. Now, like radicals means there must be the exact same thing inside the radical. So if I have square root of 5 plus square root of 7, I can't add those because they're not like. Okay? Now I have 3 square root of 2 minus 2 square root of 2's. So that means I only have 1 square root of 2 left, or just square root of 2. I'm not going to write the 1. Again, that looks kind of weird, so I'm not going to do it. Okay. Now we're going to go ahead and add and subtract radicals. So let's do number 1. You always want to check, do I have like radicals? And you do. They're both have a 6 on the inside. So you want to make sure the radicals are the same in the inside. And since they are, I can keep going. So I have 3 square root of 6's, and I'm adding 4 square root of 6's. So in total, I have 7 square root of 6's. So 7 square root of 6. Okay? Same concept as combining like terms. Number 2, I have negative 3 square root of 7 plus 5 square root of 7. So really, you're just doing negative 3 plus 5, which is 2, and then your radical is the same. Now, before you stop, you always want to check to make sure your radical is as simplified as possible. So if you can simplify it, you need to. Since 7 is prime, I don't need to keep going. And since 6 doesn't have any pairs to take out, I can stop there. Okay. Number 3. So I have 2 square root of 6 minus 2 square root of 24. Those obviously aren't the same aren't like radicals, or not the same. So let's see if I factor this one. I will have 2 and 3, and that's literally it. I don't have any pairs. So that one doesn't simplify any further. But I can simplify this one over here. Now I'm going to pick, let's pick 4 and 6. When I pick 4 and 6, I have 2 and 2, and 3 and 2. Let's pick 3. Okay, so these go in a pair together, and these are the leftover children in my house, okay? So that would give me 2 square root of 3 times 2, because I have 1 car, or 2 square root of 6. I'm going to go ahead and simplify that over here. So I'm going to copy what I had down. So at the beginning, I had 2 square root of 6 minus the 2. Remember, this doesn't go away. So, whoa, I'm going to hit the orange color. So all of this we didn't mess with. All we did was simplify that radical. So I copied that down here. And then lastly, I'm going to tag on that green spot, or that green stuff, 2 square root of 6. Okay? So I'm replacing that square root of 24. And then I simplify this. This is going to be 2 square root of 6 minus 4 square root of 6. And I end up with having negative 2 square root of 6's. Okay? Just like combining like terms, very similar. All right, number 4, always want to check both things, everything for like radicals, and see if you can simplify them any further. This is going to be 5 times 3. Both of those are prime, no pairs. So 4 square root of 15 is as simplified as I'm going to get, but 240 can simplify. So I'm going to pick 24 and 10, and that's going to give me 6 and 4, and that's going to give me 3 and 2. This will be 2 and 2, and 5 and 2. Okay, so let's look at all of our pairs here. I know I have a pair of 2's here, and a pair of 2's here. I forgot to cross out this 10. And then I have some children left over. I have a 5 and a 3. So I have 2 children that are back in the house. So, whoa, that was loud. All right, so from the beginning, I had 4 square root of 15. And then I had the minus sign. And now I'm going to write down my 2 cars. I had 1 car, which is a 2, and then another car, which is a 2. And then in the house, I have 3 times 5, because those are the children I have left over. And then in this step, I'm going to simplify. I have 4 square root of 15 minus 4 square root of 15. Well, those are the exact same thing. If I have 5 and I take away 5, I get 0. So if I have 4 square root of 15, I take away 4 square root of 15, I have 0. Okay? All right, so we have 2 more problems left. Now these have 3 terms, but you do treat them the same. So you always want to look for like radicals. So you might have to simplify all of them to get them to be like. And sometimes you just can't combine them at all. So we'll see that here in a little bit. So the first thing I'm going to do the first one in red. This is going to be 9 and 2, and then 3 and 3. Okay, so I have 1 parent pair and 1 child. Okay, so the 3 from earlier, I'm going to write down here in orange. And then the red is the new stuff. So that's 1 car, which is red, and then the lonely child inside. It sounds sad to say lonely child. Okay. And then here we're going to factor the 12. That's going to be 4 and 3, and then 2 and 2. I have 1 pair of parents, 1 lonely child. Again, that plus 3 is going to stay there from earlier. I don't mess with it until the very end, because they're basically the parents that are already out on a date, so you don't want to mess with them. Okay, so the green part is my simplified radical of square root of 12. And then lastly here I have 9 times 3 for 27, and then that would be 3 times 3. So I have a pair of 3's and then a 3 by itself. One last time, remember that 2 is already on its own, so I'm going to put the 2 there, and then I'm going to tag on the blue stuff. So I have 1 parent car, which is the 3, and then a 3 on the inside. And now I'm going to simplify. So I have 9 square root of 2 plus 6 square root of 3. Sorry, I'm trying to double check to make sure I simplified. Something doesn't look right, but I think I might just be going crazy. I believe that's right, actually. I filled in notes so I can check myself. So let's double check. Do-do-do-do. Oh, I just messed up in the filled in ones. Okay, we're good. We are good. Okay, and then I have plus 6 square root of 3. And then here you're always going to look for like radicals that you can combine. In this case, I can combine these and these. All right, so since I can combine those, I'm going to combine them. But the 9 square root of 2 can't combine with anything, so that's just going to stay the way it is. And then I have 12 square root of 3. Okay? All right, so if you feel pretty confident about this, go ahead and try number 6 on your own, and then you can kind of fast forward and check your answer. But I'm going to work it out in a second. I'm just double checking number 5. Yeah, I did that one right. Anyways, okay. Number 6, again, you're going to, I can't speak, simplify your radicals. So that's going to be 4 and 5, which is 2 and 2. Okay, the negative 2 is going to stay out there. So I have times my 2 car and the 5 on the inside. Next I have square root of 18, which is 9 and 2, 3 and 3, pair of there, and that's going to be by itself, plus 2 times the 3 for the car and 2 for the child. And then the minus 2 square root of 5 is just what it is. So I'm just going to actually write that in orange because I can't simplify that any further. And then here I'm going to go ahead and multiply stuff out. Okay. So I do have like terms here. You want to look for like radicals, so the things that have the same thing on the inside of the radical. These are like terms, so those will combine and make negative 6 square root of 5 plus 6 square root of 2. And that is the last problem for adding and subtracting radicals. So that's really, it's not the hardest one, but it is the most tedious because you do have to simplify almost everything. But that is adding, subtracting, multiplying, dividing radicals.